Now, let us see that problem, what I asked you to work out. See the slide, please. In a batch of 10 articles, 4 articles are defective. Yesterday we did the same problem. 6 articles are taken from the batch for inspection. How many articles are taken? 6 articles are taken. Totally, how many articles are there? 10 articles are there. If more than 2 articles in this batch are defective, what does it mean? If 6 articles are chosen, how many articles are chosen? 6 articles are chosen. Then how many articles are defective in the overall slot? 4 articles are defective. If 6 are chosen, in those 6, if 2 or more than 2, or if more than 2, not 2, if more than 2 articles in the batch are defective, then the whole batch is rejected. Then find the probability that the batch will be rejected. I discussed this yesterday also. Just I read the problem and explained you. Let us see how it can be done. And whatever the problem you take up in probability, you must first write the total number of outcomes. That is, P of probability of any event E is nothing but N of E upon N of S. So N of S, you know, it is nothing but the total number of outcomes. So first of all, you write that, please, always. N of S. The total number of outcomes are totally 10 articles are there. From 10 articles, 6 articles are chosen, which can be done in 10, say 6 different ways. So in this case now, N of S is nothing but 10 to 6. Now, to apply the classical definition on probability, our denominator is fixed to be 10 to 6. Now, we need N of E here. What should be N of E? N of E is nothing but 6 articles are chosen, and the restriction there is, if more than 2 articles are defective, then the entire consignment will be rejected. So we need the probability for the consignment to be rejected. So let us take the total number of defective articles. 4. 1, 2, 3, 4 are there. So in this one, 6 total articles are chosen from all the 10. And if more than 2 articles are defective, means it must be either 3 or 4. That is our favorable here in this case. If 3 articles are defective or 4 articles are defective, then the entire consignment will be rejected. So how many total number of, first of all, always understand, you have to fulfill the restriction given. Then that means always your first operation must be fulfilling the restriction. What is a restriction? So here totally 4 articles are defective. Among them, getting 3 defective will reject the consignment. So getting 4 defective also will reject the consignment. So getting 3 defective articles, getting 4 articles is our favorable outcomes now. So here totally 4 articles are defective. From 4 articles, how many should be defective to get the consignment rejected? Is it should be more than 2. More than 2 means it may be 3 or it may be 4 also. Understand please carefully. More than 2 to be defective means it may be 3, it may be 4, it will not be 5 because total number is only 4. Okay. Now, what we did, we have chosen 3 defective or 4 defective. Okay. What should be the remaining? But totally how many are taken? 6 are taken. From 6, how many are already taken? 3 are taken. From 6, already 3 are taken. How many to be taken? 3 to be taken. 3 to be taken. How many total are there? 10 are there. From 10, 4 are defective. So how many are non-defective? 6 are non-defective. 6 are non-defective. So the remaining should be chosen from the from the non-defective items. Non-defective is 6. So 6, 4C3, 3 chosen, but 6 to be chosen. So this should be 6C3. Understand this carefully. It is 10C6. You can see the total number of outcomes. Now how this 10 is split? 4 plus 6. Why? 4 defective, 6 non-defective. 3 chosen from defective, 3 chosen from non-defective. This is one way of selection to get the consignment rejected. Okay, either this or. Either this happened or this may happen. That's what from the beginning itself I've been telling you. Or stands for plus. This plus, we have seen that it is nothing but union, addition theorem. So instead of union, you can write plus. Instead of plus, you can understand it as R plus or union or one and the same. So this may happen or this may happen. What is this? Choosing all defective articles. How many are chosen? Totally 6 are chosen. From 6, how many are already chosen? 4 are already chosen. How many are remaining? 2 are remaining. 2 are remaining. Those 2 are to be taken from the non-defective items. How many non-defective are there? 10 minus 4, 6 are there. So from 6, you have to choose 2, 6C2. So this operation and this operation, this is for and. And means multiplication. So if this happens or this happens, the entire consignment will be rejected. Understand that? So this is nothing but, if you simplify, 4C3 is nothing but 4C1. It is 4 into 6C3. As I've explained to you yesterday, don't write the factorial, but write the short form of it. 6 into, write 3 factors starting from 6, consecutive factors starting from 6. 6 into 5 into 4 upon 3 into 2, 6 getting cancelled. 5 into 4, it is nothing but 20. Plus 4C4 is 1, 6C2 is nothing but 6 into 5 upon 2, it is 15. So 80 plus 15, it is nothing but 95. 80 plus 15, it is nothing but 95. Therefore, your required probability is nothing but 95 upon 10C6. You can, instead of 10C6, remember, for the sake of simplification, you can write it as 10C4 also, because NCR is equal to NCS. These are the groups. These are the groups. There will be no internal arrangement. The order of things is not considered. So 10C6 is nothing but 10C, 10 minus 6, 10C4. So it is 95 into 4 into 3 into 2 upon 10 into 9 into 8 into 7. If you simplify this, you'll be getting the final answer. Simplify that, you'll be getting the answer. Okay, so this is how you can approach. What is the difference between the previous problem and this problem? In the previous problem, you have only one restriction. Something, if you remember the yesterday's problem, there's only one restriction, but here it is split into 2. It is split into 2. That is why it requires either this, or R stands for plus, and we have got it. This total number of outcomes in the denominator and the favorable outcomes in the numerator. So this is the solution for this problem. Let's go to another problem. It's an interesting problem, but you must be knowing the playing cards. 52 playing cards are there. I hope you all know the cards. You must know, because in the problems, the cards will be given, and you have 4 categories in the cards. Then the 4 categories are said to be 4 suits. 4 suits. This is spade, clubs, and diamond, and hearting. So these are the 4 different suits, and among them 26 are of red color and 26 are of black color, and each suit consists of 13 cards. So 13 into 4 is 52, and 13 cards you will have A's for A and A's for A, and remaining will be 2 to 10, and next will be king, queen, jack, like that. Totally 13 cards in each suit. 13 into 4 becomes it is 52 cards. So you must know that first. If you don't know, please learn them, because while teaching this probability, generally some of the students, like at least 20 to 30% in the class of the students, they are not knowing how the cards will be, how the playing cards will be, but we don't have time to discuss the cards because the time is very less here. That is why you can understand that very easily if you take those set of cards and you see that if you don't know how the cards will be, what is their face value and how the number cards will be, and all these, you please go through that if you don't know. Now the problem is based on that only. Now consider the following 3 hands of 5 cards. 3 hands of 5 cards. That means each hand is having 5 cards dealt from an ordinary deck of 52 cards. Ordinary deck of 52 cards. Okay. What is H1 here? H1 is all 4 queens and a 2. All 4 queens and a 2. All 4 are queens and a 2. All 4 are queens mean how many queens will be there? You know, each suit consists of 1 queen. So all 4 queens case is only 1. Only 1. So the all 4 queens, spade king, spade queen, let me say, queen from the spade, queen from the heartin, queen from the diamond, queen from the spade, heartin, diamond and clubs. Only 4 cards will be there always. There is no other selection for this one. So this set for H1, are you looking at the problem? See the slide please carefully. H1 is all 4 queens, all 4 queens, only one way. So you can choose it only in one way, 1C1. And a 2. And a 2 means it's a number card. It's a number card. Each suit will have number 2. That means spade 2 you will have, heartin 2 you will have, diamond 2 you will have, clubs 2 you will have, clubs 2 you will have. So how many 2s you will have? 4 2s you will have. From 4 2s you need only 1 2. A2 is given. A2. So 1 2 you need. So from all the 4 10s you can choose only 1. First operation, second operation, 1C1 into 4C1. 1C1 into 4C1. 1C1 is what? Consists of all the 4 cards. 4 are there, 4. And 4C1 is what? From 4 10s you are choosing only 1 10. So which first operation, second operation, which can be done in 4 different ways. H1 is nothing but 4. Similarly, H2 if you see, H2 if you see, it is the ace, king, queen, jack and 10 all in the same suit. All in the same suit. How many aces will be there? 4 aces will be there. How many kings will be there? 4 kings will be there. How many queens will be there? 4 queens will be there. How many jacks will be there? 4 jacks will be there. So they must be all taken from the same suit. Same suit. Okay. So same suit means this is, let me say, this is one suit. Spade is one suit. Then what are they? Ace from spade. Next what? King from spade. Next what? Queen from spade. Next what? Jack from spade. Okay? All in the same suit. And 10 all in the same suit. And a 10 also can be taken. Like 10 means, let me say, 10 spade. For your understanding, I am taking S as a spade. This is from spade suit. Similarly, you will have A from H, K from H, Q from H, J from H, and 10 from H. This is R10. I will do like this. This is one set. This is second set. What is the third set? A from diamond, king from diamond, and queen from diamond, and jack from diamond, and 10 from diamond. This is third set. And what should be the fourth set? A from clubs, king from clubs, and queen from clubs, jack from clubs, and 10 from clubs. How many are there totally now? How many sets you have got now? You can see that clearly. 1, 2, 3, 4. From 4, we need one. One such set is nothing but H2. So it is nothing but, you can understand, it is nothing but 4C1. It is also 4. This has got to be 4. This is also got to be 4. Now, what should be H3? You can understand that. That 10 of hearts, the 10 of hearts, how many 10s will be there in hearts? Only 1 is there. Only 1 is there. And the 10 of clubs, how many will be there? 10 of clubs, only 1 will be there. And 3 kings. 3 kings we need. How many kings will be there totally? Just now we discussed. How many kings will be there? Kings will be always, you can see this clearly. Spade king, heart king, diamond king, clubs king. How many kings will be there? 4 kings will be there in the set. How many kings we need in H3? We need 3 kings. We need 3 kings. So from 4 kings, we choose 3 kings. It can be done in how many different ways? 4C3 different ways. 4C3 different ways. What about the remaining? The 10 of hearts. Hearts, 10 will be only 1. So it can be chosen in 1C1 only, please. And the 10 of clubs. The 10 of clubs means for clubs, only 110 will be there. It is also 1C1. So 4C3 into 1C1 into 1C1 is nothing but 4. This is 4 ways. This is 4 ways. And this is also 4 ways. You can see that clearly. Now, see the options. H1 is more likely than H2 or H3. H2 is more likely than H1 or H3. And H3 is more likely than H1 or H2. All the 3 are wrong because equal chances of getting, because it is 4, it is 4, it is 4. So last one, if you see the fourth option, all 3 hands, H1, H2 and H3 are equally likely. It is equal chances of occurrence for these events to occur. It's a beautiful problem. If you follow this carefully, if you work out these problems on your own, really you'll enjoy working out the problems. Okay, but before that, make sure of yourself that you know all these denominations, suits, face card, number card, and all this you must know. Okay, what should be conditional event? You must know that, please, first. What is a conditional event? What is a conditional event? So, conditional event is that event when an event to occur, another event must occur. That means the occurrence of one event follows the occurrence of another event. Very simple, you can understand that. India is playing cricket with other countries. It has 2 recent matches, because I'm not I don't waste my time in looking after the cricket and all, but I know that India did not even enter into semi-finals, isn't it? The reason is there is a condition that this must get these many points to enter into semi-finals or into finals. This must get some points in semi-finals, then only it will be entering into finals. Like that, the condition is imposed there. For example, if you take A is such an event, getting admission into B.Tech, let me say, getting admission into B.Tech or getting admission into graduation. What is it? Getting admission into graduation. Okay. getting admission into graduation, whatever it is, B.Tech or BSc or whatever it is, it's a graduation generally, under graduation. And B is such an event. To get admission into graduation, you must pass 12th class. Passing 12th or intermediate, whatever it is. So passing 12th will give you admission into graduation. These are the two events I have taken. What is it? B, passing 12th, and A, getting admission into graduation. So, which one must occur first? It's common sense. You can understand. B must occur first. Then only A occurs. So, it is termed as A after B, which is nothing but a conditional event. So, A after B means B must occur first, then only you must pass 12, then only you will be getting admission into graduation. This is nothing but a conditional event. For example, another example. A is promotion to 12th class. B is passing 11th class. Should I repeat? A is promotion to 12th class. B is passing 11th class. Whether it is intermediate or CBSE or ICSE or whatever it is, passing or promotion to 12th class generally does not depend on passing 11th class. Then that is not a conditional event. That's not a conditional event. So, whatever the case generally you take up, generally, even in the sports or even in your competitions, if I, for example, now very important thing, like you have JEE main, you have JEE advance, let us take this more lively example, you'll also enjoy it. JEE main, you must get a rank below 1,50,000. Below 1,50,000. That means if 20 lakh students are appearing for this examination, you must be below 1,50,000, or if you come under non-reserved category, you must be below 75,000. That means you must be the topper among all the 75,000. You must be one of all the top 75,000 students if you belong to non-reserved category. If you belong to reserved category, generally they take 1,50,000 up to 1,50,000. So getting a rank in JEE main, if you take it as A, if you get it, then you are eligible to appear for JEE advance. JEE advance. So if I say this as A and if I say this as B, B to happen, A must happen first. B to happen, A must happen first. So whatever there in the denominator, then that must happen first to happen this one, B. Okay. So this is B after A or B given A. It is read as B after A or B given A. This is read as A after B or A given B. Given B means you must know, to this event to occur, you must know that your rank should be less than 1,50,000. This is nothing but a conditional event. So for an event to occur, there is a condition imposed. That is nothing but the conditional event. Now, basing on this conditional event, conditional probability is defined. What is the conditional probability? You have learned the definition in your board level itself. Conditional probability, that is, let A and B be any two events in a sample space S such that the first occurring event's probability is not equal to 0. If I write P of A not equal to 0 and P of B not equal to 0 if it is in the denominator, I'll write that also. So I repeat, let A and B be any two events of a sample space S, and P of A not equal to 0, let me say, then the probability of occurrence of an event B after the event A is defined as probability of A intersection B upon P of A. Because it is in the denominator, we already defined that P of A not equal to 0. This is nothing but the conditional probability. Similarly, P of A after B can also be defined. It is nothing but P of A intersection B upon P of B. So whatever is there in the denominator, that here in the denominator, that comes in the denominator again. Understand that. So how do you understand this? Now, if I apply the classical definition on probability, it is nothing but n of A intersection B upon n of S upon n of A upon n of S. So what happens? This n of S getting cancelled, and your formula now will be simplified to number of outcomes in that is A intersection B, that is number of outcomes are A and B whole divided by number of outcomes of A. What was the previous formula? Number of favorable outcomes divided by total number of outcomes. But here the denominator restricted. That's only the thing. The classical definition always holds good, but further what happens? Restrictions are imposed and the denominator changes. There it was n of S means total number of outcomes we take, but it gets cancelled anyway. We need not have to have that. So in this case what happens? N of A intersection B upon N of A. Similarly, if you write the same for this one, it is also N of A intersection B upon N of B. Understand that, please. In this case, P of B not equal to 0. This is it is understood because it is in the denominator. So I'll take an example, better example to explain this. Conditional probability. Let A and B be any two non-empty sets of a sample space yes, such that P of A not equal to 0 in this case or P of B not equal to 0 in this case. Then for the probability of the occurrence of an event B after the occurrence of event A is defined as probability of P of B after A or P of B given A is nothing but P of A intersection B upon P of A. After simplification using the classical definition on probability, it is nothing but N of A intersection B upon N of A. N of A intersection B upon N of A. Similarly, it can also be simplified. Now, based on conditional probability only, next multiplication theorem will be derived. It's very simple, and if you are given multiplication theorem or compound probability, it is also said to be compound probability, just you have to cross multiply this. That's all, nothing more than that. Cross multiply this to get the multiplication theorem. We will be discussing that now, but before that you will be exactly understanding this definition. If I take an example, two dice are taken, they are thrown, and I gave you that the sum on the dice is 8. It is given that the sum on the dice is 8, and then I ask you a question: what is the probability of getting number 2? What is the probability of getting number 2 on the dice? So in this case now, I'll keep this like this. Now, the example what I have taken is nothing but 2 dice taken and thrown. Then the total number of outcomes are 6 square. That is 36. I don't need all these things because my sample space in this case, or our sample space in this case, is restricted. Restricted to what? Total sum on the dice is given to be 8. Total sum on the dice is given to be 8. So what should be now the outcomes if the sum is 8? If it starts from 1, 6 is the maximum combination, which becomes 7. So it is not possible. So 1, 7 is one possibility, and similarly 2, 6 is another possibility, and 3, 5 is another possibility, and 4 is another possibility. And next, 5, 3 is another possibility. And 6, no other combination for this one. So how many outcomes you have got? If you throw the die twice and I gave you that the sum on the dice is 8, how many outcomes you have got here? 1, 7, 2, 6, 3, 5, 4, 4, 5, 3, 1, 2, 3, 4, 5 you have got. That is, I'll say it as N of A is 5. This is nothing but 5 I have got now. Now, what is my B in this case now? Getting number 2 and as well sum 8. Getting number 2 and as well sum 8. Getting number 2 and as well sum 8 means you can choose any one of this, but you must have 2 on the die. How many cases are there here? Only one case is there. So getting number 2, if I take it as B, then my N of A intersection B, what does it mean? Intersection means and, remember. And means sum 8 and containing 2. Sum 8 and containing 2. How many are there? Only one is there. So my N of A intersection B is only 1. So in this case now, what should be the required answer? In this case, it is nothing but P of B after A. This one, P of B after A. What is B? What is B? Getting sum and getting sum 8 and getting number 2. Getting sum 8 and getting number 2 on it. That is B. What is A? The sum should be 8. What is A? The sum should be 8. How many are there? 5 are there. So here my denominator fixed 5 and what is the numerator? 1. So 1 by 5. Understand? You need not have to write the entire sample space. In case of conditional probability, the denominator, if you write the classical definition on probability, this N of S gets cancelled. Your N of S gets cancelled. So that is why you understand the classical definition, if you understand properly, in the conditional probability, the denominator is restricted like this instead of getting 36, because 36 should be the total number of outcomes anyway that will be getting cancelled. That is why you can remember or you can see the conditional probability like this. Okay, so P of B after A or P of B given A is nothing but P of A intersection B upon P of A is the definition of conditional probability. And if you want to convert this into elements, number of elements, like number of elements in A intersection B upon number of elements in A. Intersection means, understand, it is and. Number of elements in A and B. A and B means getting number 2 and the sum 8. It is only 1. And N of A getting sum 8. How many are there? 5 are there. It is 1 by 5 like that. So it is nothing but the compound probability. And if you extend this to multiplication theorem or conditional probability, conditional probability can be extended to multiplication theorem. But before going to the multiplication theorem, let me explain to you what are the dependent and independent events. Dependent and independent events. What are the dependent events and what are the independent events? Simple. In the name itself you have that. Dependent events are those events if the occurrence of one event influences the occurrence of other event, then they are said to be dependent events. If the occurrence of one event does not influence the occurrence of another event, then they are said to be independent events. Independent events. Okay. Let us see now a question. Yes, please. Ask the question.
Hello, sir.
Yeah.
Sir, in the last problem, that die problem, you wrote in the sample space 1, 7.
Yes. Sorry. You're right. Good. Right. So it starts from what? 2, 6. Good. What's your name?
Sir, Panindra.
Panindra. Good. Thank you. Right. Correct. Okay, correct. So let me correct it. Good. Now, I wrote 1, 7. That's wrong because the die contains only maximum 6. Okay. So in this case now 2, 6 because sum is 8 and it is 3, 5 and it is 4, 4. And it is 5, 3. And it is 6, 2. Good, Phanindra. So how many are there? Totally, of course, you got 5. 5. So the answer is correct, but instead of 2, 6, I wrote 1, 7. Instead of 2, 6, I wrote 1, 7. So the total number is, of course, 5 only. And the favorable is only 1, that is 2, 6, it is 1. So required probability is of 1 by 5. 1 by 5. That's good. So now the dependent and independent events. So what are the dependent and independent events? Let us see now. Let us see. Dependent event. Dependent means if the occurrence of one event influences the occurrence of other event, then they are said to be dependent events. If the occurrence of one event does not influence the occurrence of another event, then they are said to be independent events. Okay. Now let us define now dependent events. Dependent events, let us take an example. Otherwise, example like this. Dependent events. I have a bag. In that bag, I have 17 balls. I have a bag. In that bag, I have 17 balls. Different colored balls. Different colored balls. I have taken one ball and I have seen its color. And I replaced the ball in the bag. And that event is named as capital A. And second time again I have drawn another ball, I have seen its color and I replaced it. That event is said to be event B. Now you think of it, whether these two events A and B are dependent or independent events. Like what? A is first event, we have drawn the ball. How many balls are there totally? I said 17 balls are there. From the bag I have taken one ball, I have seen its color, I replaced it. And second time I have drawn another ball and I have seen its color, I replaced it. Then they are dependent or independent events. Common sense. Common sense. If it is a dependent event on A, then the total number of balls must be changed. In the first case, there are 17 balls. Because I have replaced the ball, in the second case also, total number of balls remains the same, 17 only. Understand it, please. 17 only. So these two are said to be independent events. If the ball is replaced in the bag, the occurrence of first event is no way influencing the occurrence of second event because the total number of balls are remaining the same. But in the first event, I have taken a ball, I have seen its color, I liked its color, I like this color, and I have not replaced that ball in the bag and I have kept it in my pocket. And second time, I am drawing another ball and I have seen its color. Of course, that event is named as B. So what happens? The occurrence of first event, the ball taken but not replaced and it is kept in the pocket. In the first time 17 balls are there. Now second time only 16 balls are there. There is a total number of balls are changing. That means the occurrence of event A is influencing the occurrence of event B. That is why they are said to be dependent events. Simply they are said to be dependent events. So you must know clearly the difference between the dependent and independent events. In the definition itself, in the name itself, you can understand dependent means the occurrence of first event influences the occurrence of the second. Independent event means the occurrence of one event does not influence the occurrence of another event. Okay, now we will define now multiplication theorem. Multiplication theorem or compound probability. What is the multiplication theorem? Multiplication theorem is simply, it is got by P of A intersection B is equal to P of A into P of B after A. So what does it mean? It is multiplied. That is why it is said to be the multiplication theorem. Simply whenever you're asked to, even the board level also, whenever you're asked to find out or derive the multiplication theorem on probability or compound probability, then first of all you must write the definition of conditional probability and then simply cross multiply to get the statement. P of A intersection B is equal to P of A into P of B after A. So this is to be used when you get dependent. Understand that. This is to be used whenever you have dependent events. But when there are independent events, how do you write this? This is very simple. Very simple. Like when they are independent, B does not depend on A. Irrespective of the occurrence of A, B occurs. That means it nowhere depends on A. That means P of B after A becomes P of B simply. We don't need to know about A. That is why if there are independent events, understand P of A intersection B is nothing but P of A into P of B if they are independent events. I'm very happy today because some of the students are sincerely following my lesson, because I wrote 1-7 and he immediately pointed it out. I'm very happy. If you have any such doubts or whatever the requirements you have, please call up and tell us, and accordingly we will I'll modify my teaching according to your needs. Okay, if you have any doubts, you just mail us, and through that mail we will respond. Okay, so this is multiplication theorem on probability. For dependent events, it is P of A intersection B is equal to P of A into P of B after A, and P of A intersection B is equal to P of A into P of B. No need of knowing about A, because they are independent. So simply in this case intersection becomes into. Then you might get doubt, how do we know, sir? How do we know it is dependent, it is independent, and we are getting confused while working out the problem? You might have come across this type of problem. There are 3 students. Their capabilities of solving a problem is given. Let me say 1 by 3, 1 by 4, 1 by 5. A problem is given to the 3 students, whose capabilities of solving the problem is 1 by 3, 1 by 4, 1 by 5. And I need the problem to be solved if all the three students try to solve the problem. If all the 3 try to solve the problem, then in such a case, it's common sense. The intelligence is independent, because my intelligence does not depend on his intelligence, and his intelligence does not depend on third one's intelligence. So understand that, please. Understand that. That means unless and until you copy from the others, your intelligence is always independent. Do you understand? So in the case A intersection B intersection C, you can straight away write intersection as into. So that's our common sense. So in such type of problems, you think more generally. Whenever a problem is given in a class, 30 students are there, a problem is given in the class, and you're asked to solve the problem independently. That's what I'm saying, independently. Then in such a case, what happens? Intersection becomes into. Okay, so we'll work out more and more problems on this one